when it is heated, you have zinc 2 oxide, nitrogen 4 oxide, and oxygen. Also, zinc carbonate. So you have, when it is heated, so you have zinc 2 oxide, which is zinc oxide plus CO2. So these are the 3 ways by which zinc 2 oxide can be prepared. Properties: it is a white insoluble powder which turns yellow on heating. So when it is cool, it is white, and when it is heated, it turns yellow. That is one of the properties of zinc oxide. Being amphoteric, it dissolves both in acids and alkalis. So it has the characteristics of acids and bases. That is why it is known as an amphoteric oxide. It is used as a white pigment in paint. The white pigment that you have in paint is as a result of zinc oxide, and as a filler for rubber. It's also used as a filler for rubber. It is used as cosmetic powders and creams and ointments and lotions. Zinc hydroxide preparation: it is precipitated when a little sodium hydroxide solution is added to aqueous solution of zinc 2 salts. This is zinc hydroxide. When you have an alkali such as sodium hydroxide being reacted with zinc 2 plus ion, here you have zinc hydroxide being precipitated because it's a solid. So it is insoluble in the reaction, so it comes out as a precipitate. Then you have this. So this is how it is being prepared, where this is precipitated out of the solution. Properties: it is an insoluble white gelatinous solid which is amphoteric like the oxide. Thus, it reacts with both dilute acids and alkalis. Zinc hydroxide is also soluble in SS ammonia or ammonia solution, forming an amine complex ion. Zinc tetrasulfate 6 salt preparation. It is prepared in the laboratory by the action of dilute tetrasulfate 6 acid on zinc metal. We are talking about zinc tetrasulfate 6 salt. It is established that it is prepared by the action of tetrasulfate 6 acid on zinc salts. So that is how zinc 2 tetrasulfate 6 acid is being prepared. Properties: it decomposes on stronger heating to give zinc oxide and sulfur 6 oxide. Zinc sulfate, when it is heated strongly, it gives zinc 2 oxide plus SO3, that is sulfur 6 oxide. Uses: it is used in treatment of certain skin diseases. It is used in making rayon and agricultural spray. It acts as a raw material in the manufacture of white paint and boric acid, which is used as oil lotion or eye lotion. It is used as an eye lotion. Zinc hydroxide preparation: it is prepared by the action of zinc oxide on dilute triazonitrate 5 acid. Zinc 2 oxide, also known as zinc oxide, with dilute triazonitrate 5 acid. So here you have this as a product. You have zinc 2 triazonitrate 5 salt plus water as the byproduct. This is the compound. Properties: it is a white deliquescent substance. When I say deliquescent, it means it absorbs moisture from the atmosphere and eventually turn into solution. Anhydrous salt is unknown because it is easily decomposed to give zinc oxide, nitrogen 4 oxide and oxygen. An anhydrous form of this is not known because it is very unstable and it decomposes to zinc 2 oxide, nitrogen 4 oxide, and oxygen. Allos. An alloy is a substance prepared by adding 1, 2, or more elements to a parent metal to obtain desirable products. Examples are brass, bronze, duralumin, steel, alnico, soft solder, etc. Questions. What are transition elements? Number 2. Which constituent is common to soft solder and bronze? Number 3. What are alloys? Explain why alloys are used in preference to the pure metals. 4. The main ore of lead is dash. 5. Explain why lead is not attacked by dilute acid. Answers. Transition elements, they are elements or metals with partially filled d orbitals. Question number 2. Which of the constituents is common to soft solder and bronze? In the case of soft solder, you have tin, lead. And in the case of bronze too, bronze you have copper, tin. So the constituent element that is common to the two is tin, and you have tin here, you have tin here. So the constituent element that is common to soft solder and bronze is tin. Question number 3. What are alloys? An alloy is a substance prepared by adding 1 or more elements to a parent metal to obtain desirable products. Remain part of question 3. Explain why alloys are used in preference to the pure metals. Alloys are used in preference to the pure metal simply because there is addition of other elements which makes it of better quality than the pure metals. The addition of other elements gives it a better quality compared to pure metals. That is why it is used in preference to pure metals. Question number 5. Explain why lead is not used for dilute acids. Lead is not used because it is attacked by dilute acids such as hydrochloric acid and tetrasulfate 6 acid to form protective layer of lead 2 chloride and lead 2 sulfates. Lead cannot be used for the reaction with this kind of acid, which is dilute hydrochloric acid, because it forms lead 2 chloride and hydrogen gas, which this act as a protective layer. Also, with tetrasulfate 6 acid, you have lead sulfate plus hydrogen. So, and this also forms a protective layer. So that is why lead cannot be used on dilute acid, because of the formation of protective layer of lead 2 chloride and lead 2 tetrasulfate 6 salt. Roles of government in preventing chemical degradation. 1. Strict laws should be passed to make factories keep air pollution down by using anti-pollution devices. 2. Machinery should be improved so that more efficient fuel combustion occurs. 3. People should be educated to make them aware of the causes and dangers of chemical degradation. fats and oils. Fats and oils belong to a general group of compounds known as lipids. Fats are solid, usually of animal origin, while oil are liquid, mainly from plant origin or mainly from plants. Example of fat is propane 1,2,3-triol. This compound is called propane or propan 1,2,3-triol. So this is a typical example of fats and oil. Physical properties are fats have higher melting point because they are composed of a higher proportion of esters of saturated fatty acids, while oils have lower melting point because they are composed of higher proportion of esters of unsaturated fatty acid. The major difference between fat and oil is that in fat you have esters of saturated fatty acid, while in oil you have esters of unsaturated fatty acids. Chemical properties of fats and oil. Saponification. Saponification is an important process in the chemistry of fats and oil. What is saponification? Saponification, this is the hydrolysis of fats and oil with caustic soda or caustic alkali to yield propan 1,2,3-triol. So it has to do with the hydrolysis of fat and oil with an alkali, usually sodium hydroxide, to yield propan 1,2,3-triol.